Hey guys, we are on 6.5, Conditions of Rhombuses, Rectangles, and Squares, Part 2. This is Part 2. We did Part 1 in class. And what we'd want to know is we want to determine if the coordinates of a parallelogram can be classified as a rectangle. So right here I've given you coordinates of a rectangle. A is 3, 7, B is 10, 7, C is 11, 12, and D is 4, 12. My hint to you is to find the slopes. And if your slopes are opposite reciprocals, your lines are perpendicular, meaning they'll be 90 degrees, and it will be a rectangle. So we're going to start by finding the slope of AB. All right, AB. And I'm going to do, let's not forget that slope equals y2 minus y1 over x2 minus x1. All right, so that's going to be 7 minus 7 over 10 minus 3, which gives me 0 over 7. And 0 over 7 is simply 0. So we now know that the slope of AB is 0. Now we want to find the slope of BC. So I'm going to do 12 minus 7 over 11 minus 10, and that will give me 5 over 1, or simply 5. And we know that the slope of BC equals 5. So I'm going to go ahead and highlight these slopes. Highlight these slopes. And continue finding my slopes. So now I'm going to move on to CD. And CD is going to be 12 minus 12 over 4 minus 11. 12 minus 12 is 0. And 4 minus 11 is negative 7. Well, 0 over 7 is simply 0. And we now know that the slope of CD equals 0. And then we can continue to find AD. So we would say that AD is equal to 12 minus 7 and 4 minus 3, over 4 minus 3, which would give me 5 over 1, or 5. And we would say that the slope of AD equals 5. Okay, so we have some slopes. All right. None of these slopes are opposite reciprocals. So it cannot be a rectangle. Therefore, it's not a rectangle. All right, so these would not be a rectangle. We have no perpendicular lines here, no opposite reciprocals. The next step that you would have to do if it actually was a rectangle, maybe I should go back to that. If it actually was a rectangle, you would have to do your next step, okay? And that would be proving the diagonals are congruent. Okay, so that would be AC has to be equal to BD. And to do that, you would use the distance formula. Which would be x1 minus x2 squared plus y1 minus y2 squared. But we don't have to do this. We don't have to do this time because our slopes aren't perpendicular. Our slopes aren't perpendicular. Okay, so that's that one. The next thing that we'd want to do is, I think that's all I want to give you for 6.5 notes. The rest I feel like we could probably do ourselves. Maybe just one more example problem. So let's do this example. Here's another example. All right. Use the rhombus part to solve the problem. B-A-R-T. Okay. All right, well, I'm going to go ahead and draw in some diagonals here. Here's one diagonal, and here's another diagonal. And where the diagonals cross, I'm going to call that point K. So I'm going to tell you the measure of angle RKA equals 13x plus 25. And that's in degrees, right? Because it's an angle. And I want you to solve for x. Okie doke. So RKA, that is this angle right here. Okay? Well, let's not forget that diagonals of a rhombus are perpendicular. So this equals 90 degrees and this equals 90 degrees. That means I'm going to take this expression right here and set it equal to 90. 13x plus 25 equals 90. I'm going to subtract 25 and subtract 25 and have 13x equals 65. Divide by 13, divide by 13, and x equals 5. And congratulations, you are done with that example and your 5.4 notes. Have a good night, guys. Don't forget to hit like and subscribe.